let's look at the limit as x goes to infinity of x to the 1 over x. Now the first thing we should note is that this limit is in an indeterminate form. It's in the indeterminate form infinity raised to the 0. So we use IF to denote indeterminate form, and this is infinity raised to the 0. Now there's a common technique that we can use to rearrange this indeterminate form to get it to a place where we can evaluate the limit, and that method involves the fact that e to the natural log of x is equal to x. And let's see how this fact applied to x to the 1 over x can help us evaluate this limit. So I'm going to take the limit as x approaches infinity of x to the 1 over x. And now I can rewrite this as the limit as x approaches infinity of e to the natural log of x to the 1 over x. Right? Because e to the natural log of x to the 1 over x is just x to the 1 over x. Now, my properties of natural logs tell me I can bring the 1 over x down and multiply it in front of the natural log of x. So I can rewrite this as the limit as x goes to infinity of e to the 1 over x times natural log of x. And now I know that e, if I think of the function e to the x, that's a continuous function. So I can bring my limit into the exponent. So I have e to the limit as x goes to infinity of natural log of x over x. Now let's just focus on this limit. And we note this limit is in an indeterminate form, infinity over infinity, right? As x approaches infinity, natural log of x also approaches infinity. So to evaluate this limit, we can use the Hopital's rule. So I'll put the LH to indicate that we're using the Hopital's rule in this next step. So I get e to the limit as x goes to infinity. The Hopital's rule says that this limit is the same as the limit when I take the derivative of the numerator and the derivative of the denominator. So the derivative of natural log of x is 1 over x. And of course the derivative of x is just 1. So now in my limit, I have the limit as x goes to infinity of 1 over x over 1, so essentially just 1 over x, but that is going to go to 0. So I get e to the 0 because this limit is 0, but e raised to the 0 power is equal to 1. So therefore, I have just shown that the limit as x goes to infinity of x to the 1 over x is equal to 1.